So problem 4, 2x plus y dy is equal to 2x plus minus 5 plus 2x minus 5 dx is equal to 0, and we don't have any initial conditions. Okay, this is very easy to use. So now I assume that you are very familiar with the steps that we may use to solve an homogeneous differential equation. So this is equivalent to, when we divide by dx, you find dy over dx is times 2x plus y, and you take this guy to the other side, you may find that this is minus 2x minus 5. Okay, so I took this guy to the left and then I divided by dx, or we don't need to divide by dx. So this is actually equal to minus 2x minus 5 times dx, and this guy multiplied by this guy here. So now I divide by this, so we get dy is equal to minus 2x minus 5 dx over 2x plus y. And you may divide, sorry, I did a mistake. There is here minus 5y. So here minus 5y. So now you have dy over dx is equal to minus 2x minus 5y over 2x plus y, and this is actually a function of x and y, and you may check that it is homogeneous. Okay, now you may do the same steps. Consider the change of variables u is equal to y over x. So as always, so when you derive, you may find u prime is is equal to du over dx, which is actually equals u plus x du over dx. Now you substitute by taking this change of variable. You will find that f of x and y is actually f of 1 and u. So by substitution you will find that u plus x times u prime is actually equals to minus, and here instead of x you have 1, so it is 2 minus 5u over here 2 minus u. Do you have any questions till now? It is very clear. I continue. So this leads to, when you take this u to the other side, you get x times u prime is equal to minus 2 minus 5u, and here you have minus u times 2 minus u all over 2 minus u. Now you simplify. So this is minus 2 minus 5u minus 2u plus u squared. all over 2 minus u. So let's do this quickly. Minus 2 plus 5u minus 2u plus u squared all over 2 minus u. And this actually equals to minus 2 plus 3u plus u squared over 2u. 2 minus u. Now you can separate this. So, and remember that this is x times du over dx. So by taking the u's to the left and the x's to the right, you will find that 2 minus u over u squared. Sorry, here we have, am I correct? Here minus 2 becomes 5 minus and minus 2u, so it become, sorry, in the denominator in the denominator we have 2x plus u, so here it becomes, here we have actually plus, okay, so here we have plus, so here it becomes minus, so here we have minus u squared, and here you have minus u squared. So you have minus u squared plus 3u minus 2 du is equal to dx over x. Okay? So now we compute this integral. So we take the integral of this guy plus c. So now how to compute this? You compute the delta first to check whether there is solutions or no. So you can use the decomposition onto simpler fractions. So delta here is actually 3 to the power 2 minus 4 times minus 1 times minus 2, which is equal to 9. This minus 1 times minus 2, it becomes 2. Minus 4 times minus 4, which is minus 8, which is 1. So the square root of delta here is equal to 1. And you have two solutions. u1 is actually equal to minus b, that is minus 3, minus the square root of delta over 2a, which is minus 2. So this becomes minus 3 minus 1 over minus 2. And it becomes minus 4 over minus 2, which is equal to 2. The second solution is minus 3 plus the square root of delta over minus 2, which is minus 3 plus 1 over minus 2, which is minus 2 over minus 2, which is equal to 1. So this fraction, we will simplify it into the following. So we have here minus, and you have u minus the first solution, which is 1, times the second solution, which is u minus 2. And this will be decomposed into a simpler fractions, a over the first solution, which is u minus 1, and plus b over u minus 2. Is it clear till now? So let's find a and b. So by calculation, if you calculate, you will find that this indeed equal to, we have a times u minus 2 plus b times u minus 1, and this is actually equal to a plus b times u, and we have minus 2a minus b all over the same fraction. Now now we use the identification method, so 2 minus u should equal to a plus b u minus 2a minus b. So hence this leads to that a plus b should be equal to sorry, I think there is a mistake. Let me check. So here here we have plus, here we have plus, here we have plus. So here too we have plus. So here we have plus, and here we have plus. So a plus b should be equal to 1, and minus 2a minus b should be equal to 2. The first one leads to that b should be equal to 1 minus a, and substituting b in the next equation, in the second equation, we find that minus 2a minus 1 plus a should be equal to 2. So resolving this gives minus a minus 1 equals 2. So a should be equal to, we take the 1 to the other side, it becomes minus 3. So, and this implies that b is actually 1 minus a, which is 4. Okay, so we return back to our solution. So this guy is actually equals to this guy. So I will substitute a and b with their values and multiply by minus 1. So the integral of minus 2 plus u over those guys is actually equal to minus the integral of minus 3 over the first one, which is u minus 1, and b is plus 4 over u minus 2, all of this du, which is equal to ln x plus c, as I remember. Yes. So it is a simple computation. Now you know how to compute those integrals. So what is the first one? It is equal to 3 times the integral of du over u minus 1, and the next is minus 4 the integral of du over u minus 2, and this is equal to ln x plus c. Now this is easy to compute, and this one it is easy to compute. So we have 3 ln u minus 1 minus 4 ln u minus 2, which is equal to ln x plus c. Okay. Now we substitute back the value of u. So we return to the final equation. U actually is y over x. So this leads to the integral of ln y over x minus y 1 minus 4 ln y over x minus 2 is equal to ln x. We could let it like this, and we are finished. And we could also simplify it further by taking this. It is 3 y minus x over x, and this is minus 4 ln y minus 2x over x which is equal to ln x plus c. You take this to the other side, and we take this 3 here and this 4, take it here. Okay, so what you get is so we have ln y minus x to the power 3 over x to the power 3 plus minus ln y minus 2x to the power 4 over x to the power 4, and here we have minus ln x, all of them equal to c. Now we have ln minus ln minus ln, so this becomes ln of this first guy here is y minus x to the power 3 over x to the power 3. Now we have minus here, so we should divide, and this means that we multiply by the inverse of this fraction. So it is x to the power 4 over y minus 2x to the power 4, and we have here minus, so we should divide by 1 over x, and all of this is equal to c. Now you simplify this console together, and what remains is ln of y minus x all to the power 3 over y minus 2x all to the power 4 equals this constant c. Now you could take the exponential, so you find that the final solution would be y minus x to the power 3 over y minus 2x to the power 4, all of them equal to some constant c1 that is greater than 0. And this is the general solution that we are looking for. So we may stop here today. Is there any questions before finishing the session? Uh, here هنا شوفي عندك ln x موا ln y، هذه قريناها في الترمينال، وش تساوي ln x على y، صح ولا لا؟ شفيتي عليها ولا لا؟ وعلاش؟ لاني عندي عندي انا بلي ln a زائد ln b وش يساوي ln a في b، صح ولا لا؟ دونك كي تكون عندك موا هنا وش هذه وش معناتها بلي ln x بلس ln y على بويسونس موان زان، داكور؟ وهذه وش تساوي؟ هي ln x في y على بويسونس موان زان، اللي هي تساوي ln x على y. فهمتي وعلاش ولا نزيد نفهمك أكثر؟ Très bien. Is there any questions? Is there any other questions? As you can see, we did the solution of the first and second and third and the fourth equation. So next time we will consider solving exercise number 3 and exercise number 4 of the solution. So and exercise number 5. So please, next time I will solve them very quickly. So I advise you tomorrow morning to try to resolve them yourself. So if you find any problem or any questions, you may ask me tomorrow night. Please check and revise how to solve first order differential equations and the Bernoulli's equation and the exact differential equation. I have given you the series of exercises, so try to solve on your own exercise number 3 and 4 and 5. Tomorrow, inshallah, I will go very quickly in the solution. Thank you for your attention. Sami ATAILIA, what is your question, please? So, I have told you that try to solve exercise number 3 for the first order differential equations and exercise number 4 for Bernoulli's equation and exercise number 5 on exact differential equations. Check them online and use AI like Gemini or ChatGPT to revise first order and Bernoulli's equations and exact differential equations and try to solve them on your own. So next time, which is tomorrow night, if you have any problems, you may ask them there, because tomorrow, inshallah, I will solve them very quickly, because I see now that you are familiar with differential equations. فهمت سامي ولا نعاود لك بالعربية؟ Thank you. Thank you for your attention. Next time. So good luck.